Okay, logs 3 and 4. We do these together because what it is it's called expand and condense. These are done at the same time because you need to be able to change from one to the other pretty quickly. Now what happens here is that when something is condensed, it is written as one log. So if I have log base b of xy, this would be condensed because it is one log. The log word is only there one time. So to expand it means I'm going to have many logs. And the way we expand something that's multiplied is that we take each piece and separate them with an addition sign. So we take multiply and it expands apart, it becomes bigger with addition. And the other way, if I have addition, I condense it back to one log. Now the key component here is that it does have to be the same log base, and it will be. It's very, very, very rarely that you'll ever see a problem unless it's usually a misprint, even at that. So anytime you see multiplication, we're going to separate them with addition, and vice versa. If I have addition, I'm going to bring them back together with multiplication. So if I have log base b and I'm dividing two things or three things or whatever the things are, I'm going to separate them with subtraction. And whichever one I read first, meaning the numerator, goes first. Whichever one I read second, the denominator, goes second. So if I see subtraction of two things, I can condense them back to one. If I see division, I can expand them, separate them out with subtraction. Okay. If I have an exponent expands by moving it to be a coefficient. The exponent just moves out in front of the log. That's how you expand an exponent. So you don't get multiple logs, still only get one, but it comes out front as an exponent. Keep in mind, if you have natural log, it's all the same. I can replace log with ln, and it's all going to be exactly the same properties. Alright, so we're going to do several of these, and we're just going to practice them, because that really is the only way that we get better at them. Usually, expanding is the most difficult part for us. So that's what we're going to do a whole bunch of. We have log 5 xy. So this is very similar to our original example. It's multiplication, so we get to separate with addition. Keeping in mind the base is the same. All right. If I have log x over y, if you don't see the word a number down here, its base then is considered to be 10. But when we expand it out, we still don't need to write it. It is still assumed to be 10. All exponents, doesn't matter, positive, negative, or anything in between, whole numbers, fractions. Exponents go out front as a coefficient of the log. When we have more than one thing, or more than two of what we had, it doesn't change. We just have more plus signs in this case because it's log base 5 of 2 plus log base 5 of x plus log base 5 of y. We just separate out more things. Same thing happens when we have division. Here I have log 3y to the 4th over x cubed. Now there's several steps here, so be careful with this. In this case, we have log, and then we're going to go 3y4, because this is a numerator, subtract log x cubed. Now I want to separate these. So I'm going to get log 3 plus log y4 minus log x cubed. And now I'm going to move the exponents out front as coefficients. Now I have it, oops, that's not a 4. It's log 3 plus 4 log y minus 3 log x. So there are multiple steps and multiple properties that you may need to use. In this case, we used all of them. We used the addition, we used subtraction, and we used the exponent. I do caution you to be careful when there's more than one denominator. So in this case, let's go log, and we'll do something similar here. We'll go y4 but 3x cubed. So we would still separate log y4 minus, but in this case we're subtracting all of it, 3x cubed. So now when this multiplication is separated, and the multiplication is separated with an addition sign, it's really a subtract of all of it. Now, you could leave it as a subtract of all of it, or you can say you're dividing by two things, which means you would distribute the negative sign. And you could write it as negative log 3 subtract 3 log x. You don't have to. You can absolutely leave it in parentheses. It makes no difference for log y. But just make sure that it is complete. Don't halfways do one and the other. Make sure you've done all parts of it. Alright, the next thing you need to be aware of is if things simplify. For example, if I have log x over 10. So this becomes log x minus log 10. That is true, that is correct. However, this is already in base 10, therefore base and base kind of cancel each other, so it becomes minus 1. You need to make sure you simplify all the way down. So let's try again. If I have log 4, and let's say 16x. So that becomes log base 4 of 16 plus log base 4 of x. Well, this I can do. I know what exponent on 4 gives me a 16. It's 2. You need to make sure that you simplify it all the way down. All right. And vice versa. If I'm going to go the other way, let's say this is given to me as a problem. You would need to translate this 2 up to log 4 of 16. You would know that the base is log 4, so you would say, okay, the 4 squared is 16. That's how you rewrite it into the log form, and then the expanded form back to the condensed form. And again, all of this works for natural logs. So if I had 3 natural log x plus 5 natural log y, it's expanded, so I'd be looking to condense. Exponent moves up, so natural log x cubed, natural log y 5, and then plus means write as 1, and plus is multiply. So make sure we can go in both directions, expanding and condensing, and that's logs 3 and 4.